Okay, number 11, we need to start factoring. You're right, so that we can see what our excluded values are. So first one's done, so we'll just rewrite it. Y plus 3 over y minus 7. And then the next one, luckily all of these have 1s at the front, so we shouldn't need a box to factor them. What's that first one if I have to multiply to get 12 and add to get 7?
Yeah, 3 and 4.
Okay, so y plus 3 and y plus 4. Okay, how about the bottom one?
7 and 4. Yeah.
Okay, 7 and 4.
-7.
Y minus 7. And y plus 4?
Yep.
Okay, does that make sense?
Yep.
Okay, and then right here,
Same thing, but with a 3.
all right, so we need a 7 and a 3.
Yeah.
And we need a minus 7 and a plus 3.
It's a bunch of -7s.
Yeah, well, that's good. Maybe something will cancel. And then on the bottom one, multiplies to get 49, but adds to get negative 14. Minus 7y minus 7. Okay, so before we do any canceling, let's look at our excluded values. Anything that would make a denominator turn out to be 0 is an excluded value, which looks like is just 7 and negative 4. So my excluded values are 7 and negative 4. All right, so now if you go through and cancel, if you look at just this middle term, the y plus 4s cancel.
And then the y minus 7s.
And then the y minus 7s cancel. And now I'm left with y plus 3 over y minus 7 for the first term, minus the exact same thing, y plus 3 over y minus 7. And then I have another minus y plus 3
Can you write that as one fraction?
over 1 minus 7. You know we can, but I'm not going to because this and this are exactly the same with a minus sign between them. So if you subtract two things that are exactly the same, what do they give you? Like 5 minus 5 is 0, right?
Yeah.
Anything minus itself is 0, so all that comes out to be 0.
So your answer's a
So
negative.
answer's this, right? Now when you do this problem in your sort of, it's always going to do that. You're always going to end up with these three things, and 2 of the 3 will cancel. But it might not be the first 2. It might be the first one and the last one. Okay, so pay attention to whether you, in this case, we're going to have a negative on our answer. Our answer is going to be negative, well, there's 2 ways to write this. You can write it negative with a fraction, y plus 3 over y minus 7, or you can distribute that negative to the top, negative y minus 3 over y minus 7. Everybody okay with that?
Value is 7.
Right, but I don't have to worry about the excluded. There's 7 and negative 4. I still have to put that negative 4 in there because it made the original problem denominator come out to be 0. Okay? All right, everybody okay with number 11? Okay. Okay, now when you get to number 12, the instructions change. What do the instructions say to do now?
Solve the equation.
Solve the equation. So in the previous problems, we've been simplifying. Now we're solving. So when you solve, that means you actually find an answer for x. So excluded values are very important here because if one of our answers turns out to be one of the excluded values, I would have to throw it out. So what are my excluded values?
1 and 3.
1 and 3. Okay, now think back to when we solved equations. So this is just like a reminder from middle school. If we did 1/3 plus 2/7, we found a common denominator, which was 21, right? And worked the problem like that. But what did I do if I had 1/3 x equals 2/7? This would have been an algebra 1 thing. Multiply by 21 because you'd want to get rid of the fractions, right? So this time I have an equation to start with, and anytime you have an equal sign to start with, you can get rid of the fractions. We didn't have that option when we were just simplifying, but when you have an equation, you do have that option. So what we would have done is we'd have multiplied both sides by 21, and that would have canceled these, and I'd have been left with what? 7x equals 6, and I'd have worked it without the fractions. So that's what we're going to do on one like this. We're going to get rid of the fractions. So in 1 through 11, we never got rid of the fractions. We just found a common denominator, flipped and multiplied, all that good stuff. So now, what is my common denominator for that problem?
X minus 1, X minus 3.
Yeah, x minus 1 times x minus 3 would be my common denominator. So I'm going to rewrite this thing, and I'm going to put some space between each term, and then I'm going to multiply each term times x minus 1 times x minus 3. So original problem is negative 2x over x minus 1 equals negative 2. Leave some space. Guess I'll put that minus sign there. Leave some space. 1 over x minus 3. And now I'm going to go back, and in another color, I'm going to multiply every one of those terms times x minus 1 times x minus 3. Oh, I'm going to change that minus sign over here. X minus 1 times x minus 3, and x minus 1 times x minus 3. So the red is what I had originally, and the green is I'm multiplying every term times the common denominator, which is this. So that's what's in the green, every term being multiplied by the common denominator. Okay, so now I want to focus on just this part right here. Okay, so if you want, you could put this over 1. What's going to happen to my x minus 1s? They're going to cancel. And I'm left with negative 2x times x minus 3, which I'm being thorough for your notes. If you were working that problem out for practice, you could just go ahead and actually multiply them out. Here, I got to take negative 2 times this. So I'm going to start by multiplying this green together, and then I'll save the negative 2 for the next step. So I have to take x times x, which is?
X squared.
And then I'll have a what? Negative 3x and a negative 1x, which is negative 4x. And then negative 1 times negative 3 is 3. Okay, so that's the second term. Now I have a minus sign and all of this. So when I multiply that, what cancels?
X minus 3.
The x minus 3. So then I have a negative and an x minus 1.
And now you can work it out.
And now you can just start working it out. The nice thing is all the fractions are gone. Plus 6x, negative 2x squared, plus 8x, minus 6. Now be careful on that last one. Make sure you distribute that negative to both of those so that you get a negative x plus 1. And then what am I going to get when I simplify that? What cancels?
2x squared.
Okay, the 2x squareds. If I put my x's together, here I have 8 minus 1, which is 7.
To your x.
So let me just rewrite this. I've got 6x equals 7x, what, minus 5? If I put the negative 6 and the 1 together. And so now I would subtract 7 from both sides. If I subtract 7 from both sides, I get a negative x equals negative 5. So x ends up being a 5. And so if x is a 5, is that okay? Is 5 one of my excluded values? No, so I'm okay. I can keep x equal 5 as my answer. Okay, so for number 12, the only thing that would ever make this come out to be true is plugging a 5 back in. Both sides would come out equal if I plugged a 5 in for x. Okay, ready for number 13?
Yep.
Okay. Okay, another equation. So we want to factor everything we can so we can tell our excluded values. So let's just rewrite that whole thing.
So you get 1 minus 5.
So, if I factor out a y squared, you're right. So factor out a y squared, and I'll be left with a y minus 5.
Over
What multiplies to give me
Y.
negative
minus
35 and adds to give me 2?
And y plus 7.
yeah.
Okay, plus 7 and minus 5. Equals, really nothing will factor on the other side. I could do a negative on the top, but I don't know if that would help me any. Okay, so excluded values need to be done first. What will make any denominator come out to be 0?
Huh?
What will make my denominators come out to be 0?
Oh, yeah.
A -7 or a 5. Okay, well, now these cancel, right? Which is actually very helpful. If you missed that, you just made the whole problem a lot more difficult.
So you actually have a y plus 7 squared.
What?
Y plus 7, no.
No.
Your common denominator is just y plus 7.
Oh,
It would be like having, a 12 down there instead of a y plus 7. If they both had 12s, and you multiply both sides by a 12. So all I really got to do on this one is multiply both sides by y plus 7.
jinx.
And so now when I do that, y plus 7's cancel.
Oh, because it was same.
Yeah. So now I'm left with a y squared on this side, negative 11y minus 28 on this side. So if I take that to the other side, I'd have a plus 11y and a what, plus 28 equals 0.
Are you gonna have quadratic formula now?
Well, I don't know. Is there anything that'll multiply to give us 28 and add to give us 11?
No,
7 and 4. So what's y equal to? Nope. What makes your parentheses come out to be a 0? -7 and -4. These are my two answers unless one of them is an excluded value. Oop, -7 is an excluded value, so I have to throw it out. So my only answer is y equals -4. That's the only one you would type in. If you type in both, you're going to get it wrong. And I think I have one of these on the test, and every year on the test, people
So,
forget to throw out the excluded
If it's an
value.
excluded value, then why?
The reason this is excluded, because these numbers up here make the denominator 0 if you plug them in. And you can't have a 0 in your denominator. So when you work the whole problem out, and it's saying, hey, the only two numbers in the world that will ever make those two sides come out equal is -7 and -4, then you have to say, yeah, but I can't use the -7 because it makes one of the denominators 0. Yeah, it'll probably make both sides come out the same, but it'll be some number over 0 plus some number over 0. And you can't have a 0 in the denominator.
Yep.
Okay? So you have to throw that out. Does that make sense?
Yeah.
Okay. Ready for number 14?
Just have the second one.
Okay, so we got to figure out excluded values again, so I probably need to factor this. What multiplies to give me -40 and adds to give me 3?
8
8
and 5.
and 5.
-5.
-5 and +8. So that means both of these are included within this one. So that is my common denominator right there, right? Nothing cancels, so I'm going to need to take every term times this thing. So I'll write this out in one color, leaving some space in between them, and then I'll go back and multiply every term times this. So I've got x times x over x minus 5 minus, leave some space, 4 over x plus 8 equals x squared over x minus 5 times x plus 8. And so now I go back in the other color. I'm going to multiply by my common denominator, which is x minus 5 times x plus 8. Every term. You can see that there. That's an x minus 5 times an x plus 8. And then I got to do it over here as well. So the red is the original problem. The green is what I'm multiplying every term by.
So you're gonna cancel what you can.
Yep, cancel out what?
The x minus 5.
X minus 5s. And now I'm left with x times x plus 8. I put the x first because that's the way we're used to seeing it. If you were actually working it out, you
X squared plus 8x.
x squared plus 8x, yep. Now the x plus 8's cancel. Now be careful here. Don't forget that there's a minus sign here. So I've got a 4, a negative sign, and an x minus 5. So minus 4 times x minus 5. So yeah, it'll be negative 4x plus 20 when we multiply it out. Is equal to, over here, both of these cancel, and all I'm left with is an x squared. So now I've got x squared plus 8x minus 4x plus 20 equals x squared.
Cancel the x squareds.
Mm-hmm.
Subtract your 4x from 8. 4x equals negative 20. X equals negative 5.
Oh, and what were my excluded values? I never even wrote them down.
5.
Ooh, 5 and negative 8. So is it okay to have a positive or have a negative 5?
Yeah.
Yeah. So that is an okay answer. Now, if that would have been a positive 5, you'd have had to throw this out and your answer would have been no solution. Okay? Everybody okay with 14? Okay, we only got 2 problems left, and they're the story problems, and they're actually easier than these. All right, so if Evelyn were to paint her living room alone, it would take 3 hours. Her sister Fran can do the job in 6 hours. How long would it take them working together? Okay, so let's write a rate for each of these. If Evelyn were painting, what's her rate? What's Evelyn's rate? 1 room in what?
3 hours.
She can paint 1 room in 3 hours. What is Fran's rate? 1 room in 6 hours. So are Evelyn and Fran going to work together?
Yes.
Okay, so if they're going to work together, now let's add them together if they're going to work together, right? And so we want to know if they do work together, they would be able to paint this 1 room in how many hours? So we'll put an X there. So this is Evelyn's rate, 1 room in 3 hours. Fran's, add them together, we get a result of 1 room in how many hours? So how could I work this problem out?
Common denominator.
Which would be what?
6.
Close. You have 3 fractions there.
Oh, whoops.
What about the X?
So 18.
So, okay, you could do 18x, but I would just do 6x, because 3 goes into 6, okay? Now, this is an equation, so I can get rid of the fractions by multiplying by that common denominator. So I'm going to take every one of these and multiply it times 6x. So I will rewrite 1/3 plus 1/6 equals 1 over x, and I'm taking every term times 6x. So,
Two.
so 2x, okay. Second term,
X.
6 is canceled, I'm left with just an x. X is canceled, and you got a 6. 2x plus x is, so I have 3x equals 6, so that means x is what?
2.
So if Evelyn and Fran work together, they can get that room painted in 2 hours,
That's close.
okay? Which we knew Evelyn could do it by herself in 3, so we knew it had to be less than 3 if she was going to add in Fran's help, okay? Everybody okay
How I look at it,
with
Fran
number 50?
just holds each other back, so it's going to take at
Yeah.
least 4 hours.
Mathematically not true. But. All right, number 16. Okay, similar type problem. We've got a lake. Whoops, I went a little too far, didn't I? All right, so officials began to release water from a full man-made lake at a rate that would empty the lake in 12 weeks. But a river that can fill the lake in 20 weeks is replenishing the lake at the same time. How long does it take to empty the lake? So this is kind of like Pomme de Terre. Okay, you guys ever been to Pomme de Terre? Okay, Stockton, any of those Missouri lakes? Most of them, a lot of them are man-made. And There's a dam damming up the water, but there's usually a river on the other end feeding into the lake a lot of times. Palm de Terre knows that way. So what they're saying here is they're releasing water from the dam. And if they release water from the dam, that would empty the lake in 12 weeks if nothing else was pouring into it. It never rained, the river wasn't running into it, okay? But we do have a river on the other end, and it can actually, if the dam is completely closed up, it'll take 20 weeks to fill the lake at that rate, okay? So let's write these as a rate. They're releasing water from the dam at a rate of what? One river can be emptied in how many weeks?
12 W.
One river can be emptied in 12 weeks. But I have this river, or I should say lake. The lake can be emptied in 12 weeks. But now I have this river pouring into it, and it can fill it in 20 weeks. So that's one lake filled up in 20 weeks. One river emptied, or one lake emptied in 12 weeks. So are these two working against each other or with each other? Against, right? This one's trying to empty, but this thing keeps filling it up. So if they're working against each other, we'd want to subtract that. And so that's going to end up with what? One lake being emptied in how many weeks? Okay, well, obviously we know the answer is going to be more than 12, right? Because if the river never existed, they could empty it in 12. But now working against that, so it's going to be more than 12. So what would I need to multiply by? What's my common denominator here?
60.
Okay, 12 and 20 both go into 60.
What?
12 and, you're right, it goes in there 5 times. 12 and 20 both go into 60 evenly, and I have an x, so my common denominator is going to be 60x. So take every term times 60x. So 60 and 12. 12 goes into 60 how many times?
5.
Okay. So 5 times x is 5x. 20 goes into 60 how many times? And then here, what happens to the x's? And you're left with?
660.
Okay, so now I've got what? 8x, 2x equals 60.
Oh, I'm smarter than this.
Yeah, I added for some reason instead of subtracting. 2x equals 60, and x is equal to, so it's going to take 30 weeks to actually get that thing emptied because of that river flowing in there. Okay, does that make sense? All right, that's it.